So I'm going to take two masses here. And I'm assuming that the spring is not going to get caught up on anything. There's one without spring. Oh, I do have two without. I'll use two aluminums so that they're the same mass. What I'm going to do is I'm going to flick them off the table. I'm going to flick them so that they are going at different speeds when they come off the table. So I'm just basically going to do that. This one will be going faster because it is farther from the pivot point. Greater torque is being applied to bring in some chapter 9 stuff. I'm going to flick them, and the question is, so this will be going faster than this, which will hit the ground first?
The one closer to the pivot.
So this one?
Yes.
So I guess we have, let's see if physics by democracy works. Sometimes. So I've got the one that's just basically going to do this, and I got the one that's going to be doing that. We'll call that one A, and that one B, and I guess the other is a tie, and then the other choice would be neither.
Neither.
They both burst into flames and disintegrate before they get there.
How do you neither?
All right, so let's just assume for the sake of this that they do not burst into flames. They do not disintegrate. Who thinks A is going to hit first? Have an opinion, whether you can back it up or not, just have an opinion. So 1, 2, 3, 4, 5. Who says B is going to hit first? Set a hand back there. Fine, so I tie. 1, 2. That's everyone. All right. Any of you willing to bet your physics grade on it?
I'll wager
Oh.
1 point.
If the second one hits first, give me 100 for the class.
100 for the class.
1 point
Looks
of
like
extra,
class is not really an assignment.
1 point of extra credit. Otherwise, you can take a point off of that quiz.
Anytime, if we're gonna bet for actual points, then the points actually don't mean anything. So, all right.
Get a sticker or something.
What was that?
Now win a sticker or something.
I still missed part of that.
Like a sticker.
Oh,
Blowing a sticker.
a sticker. If I had stickers, ooh, I could start doing stickers instead of betting mythical points. All right, here we go.
Actual rewards.
That was pretty darn close.
Yeah, but it was a.
But it was
It was a.
A hit first?
Yeah.
I really couldn't tell which one hit first. But it probably depended upon which one actually went off the table first. So it's quite possible A did go off the table slightly ahead. But the fact that they did hit about the same time, despite the fact that that one was going faster than this one was, and you could tell that because it's farther from the edge of the table, tells us an important thing. It tells us that whenever I have a two-dimensional problem, so what is known as projectile motion problem, I can treat that as a horizontal part and a vertical part. In other words, if I can figure out how much time it takes an object to fall, I can figure out how much time that one was in the air. Let's do a simple problem there. I'm going to rewrite the cake formulas over on the side. So we have VF equals VI plus AT. We have VF squared equals VI squared plus 2A dot delta S. Delta X is VI plus VF over 2 times time. And delta X is T plus 1/2 T squared. So I'm just going to pretend it's a meter tall, make the life simpler. So I have something being shot off a table. Initially going, let's say 1 meter tall. horizontally. And what I would know is how far from the bottom does it land? I'm gonna cleverly call this R for range. So this is two problems. I have how long it is in the air, and then how far will it actually go horizontally. So the way that I treat this is I have to treat it like a two-dimensional problem. I can't just get away with plus and minus, I have to add something else to it. Because we are now dealing in 2 dimensions, I'm gonna define an I hat and a J hat. So I'm just gonna say I hat is in the direction it initially goes, and then J hat either up or down, it does not really matter. One of them is positive, one of them is negative. Any preference? Which one's positive? I mean, up or down? Okay, trying to figure out where is J hat positive? Is J hat positive up or J hat positive down? Okay. Because Alan said so. Now, so basically I have displacement, initial velocity, final velocity, acceleration, and time. I'm gonna have an I hat and a J hat part to it. So what do we know? I'm looking for, I have potentially 10 different things. This is what we're ultimately trying to find. We're trying to find that the horizontal displacement.
What is that, 4 meters per second?
That is initially how fast it's going when it comes off the edge of the desk.
Right, so that's initial velocity on the I hat side.
Yeah, it's initially being shot that way, so initial velocity here is 4 meters per second. Do you know that?
Okay.
We've got a couple other pieces of information.
On the J hat side, the change in X is 1 meter.
Almost, not quite.
Negative
Yeah.
1 meter.
Because Alan said up was positive, it would be negative. So negative 1 meter. There are 1, 2, 3 more pieces of information that we know.
The acceleration
Is
is 9.778.
9.798.
That one,
So you think the problem's taking place in Winston-Salem?
9.8.
So
Is it taking place in Winston-Salem? It's taking place right here. Is it in Winston-Salem?
Okay, so we'll make it 9.798.
Okay.
That would be
Or negative. It's
Negative.
Going down.
Down,
Yes.
no horizontal.
Well, there is horizontal movement for it because it's sliding across the table.
So one thing, we have it initially going 4 meters per second off the edge here. How it got to 4 meters per second, we don't care about. We care about once it is launched into the air. Okay, we are ignoring the air resistance. So the horizontal acceleration about, with sliding across the table, that's before the problem starts. So the 9.798 meters per second squared down. So
would be negative on the J hat.
okay. So negative 9.798 meters per second squared on the J hat side. And on the horizontal side,
Same thing? Okay.
Horizontal,
Like,
just be 0 for the horizontal?
it would be
side?
0. Once it is in the air, the only force acting on it is the force of gravity, which is downwards. Again, down is defined by the direction of the gravitational pull of the smaller object. Because the only force acting on it once it is in the air is the force due to gravity, the acceleration is also down. And there's nothing horizontal. All right, we've got one other piece of information. Natalie?
Would the final velocity be 0?
No. All right, so this gets into a common misconception. It is going to hit the ground. It is common in physics problems to say, how far does it go when it hits the ground, or what's the final velocity when it hits the ground? Even though we talk about it hitting the ground, we're actually talking about the point just before it touches the ground. So the final velocity is not 0, because once it hits the ground, we've introduced another force, and the acceleration is no longer a constant, and these equations don't apply anymore. But there is one other piece of information.
The initial velocity,
Keep
I'd
going.
say that, but the 0.
Yeah. It's initially coming off the table at 4 meters per second horizontally. There is no vertical component. We have two pieces of information over here. Yes, we could solve for final velocity here. It's not going to give us any new information, so it does not allow us to solve for this. We do have three pieces of information over here. We can solve for the other two if we need to. So when you're doing it, first thing, separate it up into the horizontal and vertical components. Matter of fact, more specifically, set it up into a component that is parallel or anti-parallel to the acceleration, and the other one perpendicular to that. Because we want one of the accelerations to be equal to 0, the other acceleration is not. That is going to come into much greater importance when we get to chapter 4. There is one of these things that will be the same for both, and that is time. The time is that which binds the two components. It will be in the air horizontally for the same amount of time that it's in the air vertically. So we have to solve for time. We'll use the vertical piece, find time, then we'll know this, then we can solve for this. So, given what we have for the vertical, which equation would we use to find time?
Fourth one.
Okay. So I've got -1 is equal to 0t plus 1/2 negative 9.798 t squared. Now what?
You solve for t.
Okay, yes, that is true. How?
Times in multiplied by 2.
So I got -2 equals negative 9.798 t squared.
Take the square root.
And what's,
Wait, no, wait. Now you divide it by negative 9.7.
I would recommend that, you could do the square root,
if you do a square root of negative number on your TIs, does it give you a complex number or an imaginary number, or does it say error?
Probably said there.
Okay. So t squared is equal to 0.2 something. 0.2202. Somebody's gonna tell me what it really is.
A negative 0.2041.
0.2041. It shouldn't be negative, because the
Not-
negatives
yeah,
will cancel out.
Not negative, yeah.
So that's t squared, and so t therefore is the square root of that. Point 45 something. 4517 seconds. So we now know the amount of time. 0.4517 seconds. It's the same for the other side too, 0.4517 seconds. And so now, if I want to figure out how far out it goes horizontally, which equation would I use?
The bottom one.
Yep. And so I end up with R equals 4 times 0.4517 plus 0 times time squared. Well, I guess I know time, but plus 0. Something like that. And as usual, I'm opposed to have made some errors there.
No, you got it right.
Okay. Likewise, if I told you how far out it went, we could work backwards and figure out what the initial velocity was. Questions to hear? All right, let's make it a little more complicated. Well, actually, let's make it more complicated. So what we're gonna do is we're gonna go back to the cliff. I'll make it 40 meters tall. Why not? I want to figure out how far out it goes, some distance r. This time it's going up at an angle. Initially going, put this at an angle of 37 degrees and 50 meters per second. Let's make it 36.8. All right. We're going to go through the same type of exercise that we've been going through. I got my 5 quantities there. Actually, let's set up the coordinate system. I am going to set it up so that it's going in the positive direction initially, in I hat and j hat direction. In the videos, I often don't use I hat, j hat. I just call it horizontal and vertical. I got my I hat, got my j hat, delta x, di, bf, a, and t. Well, without doing any math here, I can get at least 3 things. Just by the nature of what's stated in the problem. What do we know?
I had changed the position as R,
Okay.
and then J had to be negative 40.
Good. I'm writing meters in there just to re-emphasize the units that go with that quantity. Actually solving the problem, you don't have to put the units in here, just make sure the units are at the end. All right, 2 more pieces of information. And assume Earth 2.
Velocity is going to be negative 10 meters a second squared.
No,
But Earth 2 is negative 10 meters.
not for velocity.
Acceleration.
Okay,
Did I say velocity?
I heard velocity.
I'm
Well,
gonna
we
say-
have it recorded, so we can find out later on. if
I'm
we
gonna
have to.
say acceleration.
Okay. So you would have written it down correctly?
Yes.
All right, so where do I write negative 10?
J hat.
And I hat?
0.
All right, that's the information that we know right off the bat, without doing any additional math really.
The one other thing that we can do now, we have to actually use some math in order to figure out the initial velocity in the horizontal and vertical components. I know it in polar form.